start with the next chapter. Is the main brain of the power system is the generator. So generator is producing the
generation
electrical power. So in case of generator, we give the to generator we give the mechanical input. We give the mechanical power, and which leads to the rotation of the shaft of the generator at some angular velocity. So due to this, there is a production of some mechanical torque in the shaft. When we rotate, so some mechanical torque is produced. And when we rotate this shaft, so this shaft, we have some poles which are excited, so which are creating a north and south pole. So poles are rotating, and outside frame, in case of generator, we have the windings. So when the poles are rotating, then the field is also rotating. So field is also revolving. So when a revolving field cuts the conductor, then the EMF is reduced. And due to reduction of that EMF, we get some electrical output, electrical power. So due to this, we have the electrical torque is produced in the machine. So we have given the mechanical input. So due to this, your rotor starts rotating at some angular velocity omega, so leads to production of the mechanical torque, and which leads to the production of the electrical torque. And mechanical torque and electrical torque are opposing each other. So due to this rotation, the machine has some kinetic energy. So this machine is having some kinetic energy. So this kinetic energy is given by half I omega square, or we can say this, sometimes we write this as J. So I or J is known as a moment of inertia. So this machine is having some kinetic energy. When the rotor is rotating, the machine is having some kinetic energy. So due to the rotation of your rotor is rotating at some some angular velocity omega r, and some revolving magnetic field is also produced in the machine, inside the machine, and that revolving field is rotating at the synchronous angular velocity is known as omega s. Okay? And we have the relationship. So due to this, we have the angular velocity of your rotor, which is given by ns, and this is equal to phi f ns. Okay? So this is your related with the number of poles. Your angular velocity is related with the number of poles, which is equal to 120 f by so your synchronous speed is equal to 120 f by p. Okay? So accordingly, if we have a large number of the poles, then we can have the less speed, and if we have the less number of the poles, then we have the large speed. So because we are producing the power here at 60 hertz, so our standard frequency is 60 hertz. So if you consider 50 hertz, and if you consider it as a 50 hertz, then we have some synchronous speed. So now we have this, means our rotor is rotating, and rotor is revolving at some speed. Rotor is revolving at some speed, and also we have some synchronous speed. So means we have let us suppose we have this we have some rotor. So our rotor is rotating. Let us suppose our rotor is rotating in this direction. So this is rotating with respect to some stationary frame. This stationary with respect to some stationary point, it is rotating like this. So it completes 1 revolution, 2 revolutions, 3 revolutions. So accordingly, at any instant, it has some position with respect to this stationary point. It has some angular position, and this angular position we can call this as angle, which is equal to angle theta. So we also have this means the rotor is rotating at some angular velocity omega r, and we have the synchronously rotating field omega s. This is the synchronously rotating field omega s, and your rotor and revolving rotor and the synchronous field will have some angle difference. Let us put this angle is equal to delta. Okay? So when this your rotor is lying along this omega s and they are simultaneously revolving, then this angle difference is equal to 0. So our generator is producing some electrical power, and this electrical power is given by P is equal to E B divided by X sine delta. This power is given by this relationship. E is which is the EMF produced by this generator. B is if we have a generator, and this generator is connected with some infinite bus. Let us suppose this is the angle 0 degree, and this is the your voltage of the generator, which is given by E delta. Okay, so there is a difference between this voltage and this E is delta. So accordingly, magnitude of this E, magnitude of this V divided by the reactance of the connecting conductor, okay, into sine of delta, will give to the power which is transferred from this generator to towards the bus. Now if this delta is equal to 0, if delta is 0, then no power will be transferred. The generator is not producing any power in that case. So in order to produce some power, delta is required. So we need this delta. As we increase this more and more delta, we will get more and more power from the machine. But there is a limit up to which we can increase this delta. So we have this is our this synchronous rotating field and rotor is rotating like this. And if there is an angle delta and they start simultaneously revolving at the synchronous speed, then this state is known as the steady state condition for the generator. The generator is working under the steady state condition. Your rotor is rotating at a synchronous speed. Also, your volume field is rotating at a synchronous speed. But there is an angle difference between the synchronous field and the rotor field. So this is known as the steady state field. But if there is a disturbance, then your rotor speed may increase or decrease as compared to the synchronously rotating field. So under this case, this angle delta may start increasing or decreasing. Okay? So means this delta may start increasing or decreasing. So this may increase or decrease or change in this delta may leads to the loss of synchronicity. Means your machine may become unstable. So accordingly, we have the types of the stability or the power system. So we have different types of the stability. First is the steady state stability. Steady state stability. Second one is the transient stability. Sorry, before we discuss it, we have a different types of the stability. So first we start with the your voltage stability. Voltage stability. Then we have the frequency stability. And third one is the angular stability. So voltage stability. In case of voltage stability, our generator is producing electrical power, and this power is produced at some voltage level. So we have some standard voltage level because our system is interconnected system. So there should not be much variation in the voltage level. So our means the tolerance of the voltage stability is 5%. Means our this